Our next speaker I'd like to introduce is Alaa Mahjoub. Alaa is basically a former data management senior expert from the Department of Transport. I think we mentioned transport as a very important sector. And Alaa has the experience having worked in the United Arab Emirates. So without further ado, I'd like to welcome Alaa Mahjoub. Alaa, over to you.
Thank you, Sadiq, for the introduction. Number one, it is a real pleasure and honor to speak to you today. I'm Alaa Mahjoub, a data management senior expert, and I'm going to speak to you today about the integration of big data analytics with the Internet of Things and the industrial automation and control systems. I wanted to tell you something. The day before, I received a message with a comment about the subject of this presentation from one of my colleagues who is working in a top-tier IT research and advisory firm. And my friend said that it looks like a great subject. Also, I am surprised that anyone is still using big data. And I answered his comment. And in this presentation, I'm going to tell you more information about that. Our agenda today includes the business drivers, the market trends, and the architectural requirements of such a type of integration. And then we are going to go through the reference architecture that is used to implement such a type of integration in a modular and secure manner. And then we are going to end with two case study examples, one from the transportation industry, and the other one is from the petroleum industry. What are the business drivers? In fact, almost all asset-intensive industries can leverage this type of integration in addition to the integration also with small and wide data analytics to turn insights not only into strategic and operational business decisions, but even into augmented, automated, and autonomic actions. When we speak about asset-intensive organizations, we speak about things such as heavy manufacturing, utility, telecommunication, oil and gas, mining, aviation, and the transportation industry. I mentioned the word autonomic action. So what are autonomic systems? Autonomic systems are self-managing physical or software systems that learn from their environment, learn by themselves, and they can dynamically modify their own algorithms without an external software updates. Examples of such systems include smart places. And what are smart places? Smart places are things such as smart cities, smart factories, and smart homes. In addition to that, we have also physical systems with autonomic capability, such as drones, robotics, and the manufacturing machines. Also, we have software that enjoys this facility or capability, such as the software used to monitor and control security environment. In fact, autonomic and atomic actions are driven by what is so-called machine intelligence, where a machine can behave like a customer or can behave like an employee in the enterprise itself, or can behave like an employee in general in the ecosystem. And hence, decisions are taken by the machines and exchanged among the different ecosystem players via their connected operational technology systems, Internet of Things systems, industrial Internet of Things systems, cyber physical systems, Industry 4, smart mobility, smart city, and smart grid networks. Well, what are the most important market trends that affect this type of integration? The first market trend is cyber physical conversion. we mentioned some concepts interconnected to each other, such as operational technology and Internet of Things, industrial Internet of Things, cyber physical systems, smart cities, Industry 4, and so on and so forth. Let us now define each of these concepts in a precise and concise manner. When I speak about operational technology system, I speak about how do I optimize my process. For example, this driverless metro rail includes operational technology system and uses it to optimize its process. When I speak about industrial Internet of Things, I speak about how do I optimize my factory. For example, this production line has used industrial Internet of Things to optimize its production. And when I speak about cyber physical system, I speak about how do I enable safe, real-time, secure, reliable, resilient, and adaptable performance for physical assets and humans. For example, this METRORAIL network is a cyber physical system. And when I speak about Internet of Things, I speak about how do I connect anything, everything, and anywhere. For example, this service provider, maintenance and repair service provider, uses Internet of Things to automate its delivery of service and spare parts. And when I speak about smart cities, Industry 4, Made in China 2025, then I speak about how do I optimize my city, community, and economy and society. For example, this smart city includes a lot of smart networks, such as a smart mobility network, a smart electrical grid network, smart water grid network, a smart telecom network, and so on and so forth. Now, let us have an example to illustrate how all these interconnected concepts can be leveraged to and work together to provide business value in our new digital world. In this scenario, we have the metro operational technology system discover a fault in the metro rail itself. And then step 2, the metro will automatically inform the metro rail network to reschedule its trips accordingly. And it will inform automatically as well and acts as a machine customer to order and request a spare part from the maintenance and repair service provider. And then the maintenance and repair service provider wants to replenish its stock, then it orders some spare parts from the factory as well. And a lot of service provider can ask for maintenance and spare part for maintenance at the same time. Then the inventory in the factory will go low, and the factory industrial Internet of Things will try to replenish its stock by operating additional machines. And having done that, the additional machines will consume more power, and then the factory will communicate automatically with the smart grid electrical network and informs it to control the road through the transactive control system. Now, about the next market trend. The next market trend also that affects this type of integration is the accelerated pace of digital business transformation. And what is digital business transformation? It is actually the creation of new business designs by blurring the digital and physical worlds due to the conversion of people, businesses, and things. By connecting people, places, things, and information to the internet, new business opportunities are created, and business models can be rethink, reinvented, reimagined, and transformed. And why we are able to do that now? Because the new technologies of social media, mobility, cloud computing, big data, and the Internet of Things are enabling us to do that. In the digital business transformation, we have the connected people. People are generating and consuming information, social media information, calendar information, location information, and online transaction requests. In the digital business, we have also the Internet of Places. We have the connected homes, connected offices, and the connected buildings. We have the number of people in the place. We have the number of people visited the place. We have the wait times and reservation services. And in the digital business, we have also Internet of Things. Things are providing and consuming information. We have the connected buses, connected vehicles, connected taxis, and connected traffic signals. They are providing and consuming information, speed information, location information, online requests, diagnostic informations, traffic information, and so on and so forth. And in the digital business, we have also Internet of Information. We have bus schedules and expected disruptions and so on and so forth. The tremendous amount of information produced by the many people, the many businesses, and the many things connected to the internet should be utilized to create new revenues, a better customer experience, and better business processes. In this example, people made 1.35 billion journey on London tube network a year, and every weekday London sees 2 million people traveling in on the tube and 2 million traveling back. And this tube heartbeat application is used to map the London's busy underground system. And so people can find out when their local station is busiest, and the people can also find out whether their travel indeed is busier than it is used to be. The third market trend that affect this type of integration is the data and analytics driven business innovation. And for the corporation to leverage the data and analytics driven business innovation, they should exploit the data as a full scale of full landscape of the data and analytics, the full data and analytics landscape, including the people, process, and the technology, and applying all of that among and across all the data domains inside the enterprise and the relevant data domains outside the enterprise as well, external data domains, with special focus on innovative analytical initiatives such as specifically in the area of real-time continuous intelligence, data science, artificial intelligence, and the machine learning analytics, as well as other data types of big data, small data, and wide data analytics. We mentioned the term continuous intelligence. This term means it is a design pattern which is actually a type of real-time analytics integrated into business operation, and it consists of 4 steps. The first step is the observe steps, which is getting information from the environment in real time. And the second step is the orient step, which includes understanding the incoming information and determining what we can do about it. The decide step is determining the best action from among the possible reactions. And finally, the act step is to implement this decision in the field, typically in real time. We mentioned also the term big data analytics. Big data analytics is applying advanced analytics into big data sets. Then what are advanced analytics? Advanced analytics are a subset of analytics that includes things such as data and text mining, machine learning, pattern matching, forecasting, visualization, semantic analysis, sentiment analysis, network and cluster analysis, and so on and so forth. What are big data sets. Big data sets are high volume, variety, and velocity data sets. We mentioned also the term small and wide data analytics. Small and wide data analytics includes applying specific advanced analytics approach into smaller and wider data sets. The examples of this specific type of advanced analytics include federated learning, federated machine learning, analytics, which means typically combining text analytics with video analytics, with audio analytics, with structured data analysis, and so on, and applying all of that mixture into structured and unstructured content, such as text, video, audio, database, tables, and so on and so forth. And why we are mentioning this type of small and wide data analytics? Because there is a forecast that by 2025, 70% of the organizations will shift their focus from big to small and wide data, and this will accordingly provide more context for analytics and make artificial intelligence less data hungry. This is according to the Gartner strategic planning assumptions published this year. Well, based on the business drivers and the market trends we spoke about, we shall now see what are the architectural requirements that satisfy this business driver and cope with the market trend, align with these market trends. In fact, security and architectural complexity are two main challenges when I'm trying to integrate the industrial automation and control systems with the Internet of Things systems with big data analytic platform. And why is that? Because the big data analytics platform is often connected to the enterprise information system. But in turn, the enterprise information system is often connected to remote enterprise users, and not only to remote enterprise users, but also to enterprise customers, and not only with enterprise customers, but also with enterprise partners, and not only with enterprise partners, but also with other ecosystem players such as enterprise supplier. And the problem of all of that this information systems is often or in many cases connected not only to their information systems, but also to their industrial automation and control systems and the Internet of Things systems. And above all, many of all these ecosystem members or players are often connected to the cloud. And this in turn creates a complex architecture with many security challenges. So, what are the architectural requirements? We have the first market trend is accelerated pace of digital business transformation. Its first impact is more complex operational environment, and this implies the need for modular architecture that makes such complications easier to understand, easier to design, easier to implement, easier to maintain, and easier to secure. The second impact is that digital assets now and individuals are now increasingly located outside the enterprise border. And this implies the need for applying policy-based security approaches instead of topology-based security approaches. The second market trend we spoke about is the cyber-physical conversion. Its first impact is pervasive integration of consumer things through the Internet of Things and operational technology things. And this implies the need for better management of machine identities. The second impact of this market trend is the security breaches can now compromise not only the information and the data of the enterprise, but also can compromise the physical assets. And this implies the need for more robust control and safeguard the physical assets. The third trend is the data and analytics driven business innovation. Its first impact actually is applying artificial intelligence algorithms to attain autonomous and autonomic actions. And this implies the need for applying responsible AI practices for trust and confidence. And its second impact is now there are new attack types such as malicious model training, and this implies the need for artificial intelligence and machine learning model integrity verification checks. And the last impact of this trend is the move from big to small and wide data, and this implies the need for a unified integrated architecture, data and analytics architecture for big data analytics, small and wide data analytics at the same time. Now, based on these architecture requirements, let us see now how the reference architecture, let us see now the reference architecture that can be used to satisfy these requirements, these architecture requirements. The reference architecture is called the Digital Business Technology Reference Platform reference architecture, and it is a modular reference architecture and for integrating of big data analytics with Internet of Things and industrial automation and control systems. The Digital Business Technology Platform includes 5 building blocks. The first building block is the information system sub-platform that runs the core business applications of the enterprise, back office applications, infrastructure applications, endpoint device applications, and operational technology applications. And the second building block is the customer experience sub-platform that runs the customer and the citizen-facing applications such as the customer portal, business to consumers, and business to business applications. And the second building block is the Internet of Things platform that connects physical assets or things for monitoring and optimization, as well as control and monetization. And the fourth building block is the ecosystem platform, which is used to support the creation of and the connection to external ecosystems, marketplaces, and the communities relevant to the enterprise business, such as governmental agencies, smart cities, credit card networks, police, ambulance, and so on and so forth. In the central position, we have the fifth component, which is the data and analytics platform that contains the data management and analytics applications. Now, let us have a closer look at the Internet of Things platform. The Internet of Things platform connects things through gateways and agents, and these things may be owned by the enterprise itself, or can be owned by the customers of the enterprise, or can be owned by its partners. And let us have a look also, closer look at the data and analytics platform. It includes 4 architectural building blocks or layers. The first layer is the data fabric, which is used to connect and collect the data from inside the enterprise and outside world as well. And actually, it supports the big data analytics through things such as data lakes, and also support the small and wide data through things such as the logical data warehouse and other building blocks here. The second layer is the analytics and the business intelligence platform, which is used to develop the different type of analytical applications. And on the top of that, we have the analytical applications themselves. And on the top of that, we have the final layer, which is the delivery that is used to deliver the outcomes of these analytical applications inside and outside the enterprise through things such as APIs, streaming, web portals, mobile apps, voice portals as well, office applications, emails, SMS and data marketplaces, and unified communication and collaboration platforms. Now, what are the cybersecurity aspects of such a reference architecture? Actually, we have here the Purdue reference model for control hierarchy, which is a part of the IEC 62443 security standard, and it classifies the security levels of the system, the OTC and IT systems, into 6 layers and 6 levels, and we can consider it as consisting of 9 layers. The bottom layers indicated by red color belongs to mostly to the operational technology world, while the blue color layers belongs to the information technology world. Then how to leverage this best practice for integration of the industrial automation and control systems to our digital business platform. This is by applying the Purdue model here also, by including these layers into the industrial automation and control system part, and including this the best practices for the other 5 layers in the information technology part. About the Internet of Things here, how to integrate them in a safe and secure manner also. We use best practices because the Internet of Things platform connects things through gateways and agents. Then we should know exactly what is connected to our enterprise. This is by applying device identification approaches using things such as network address control and IT asset management products, and also secure authentication of these objects into our network. And the second, the best practice is to use network segmentation. How do I segment the network? I segment a network in a way that enables me to protect the edge and to protect the platform itself, and finally to protect my enterprise, because the platform is connected to the other platforms through this bus. Also, we should use network traffic analysis and leverage the policy-based security approaches, specifically with the things that are located outside the enterprise border. And we consider using best practices framework such as Industrial Internet of Things Consortium Security Framework. Now, having implemented these best practices, we have the final shape of the digital business technology platform. We have here the industrial automation and control systems are connected through the best practices we mentioned before, and the things are connected through gateways and the agent through the best practices for IoT integration we mentioned in the previous slides. About now we have these 5 sub platform. What about how to deploy these 5 platforms? They can be deployed as a public cloud model or private cloud model, or hybrid cloud, or community cloud, or on-premises. From a security point of view, it is recommended to implement them as on-premises or community cloud or private cloud. And why not through the public cloud? Because potential risks of public cloud deployment model includes things such as lack of conformity with confidential computing, and the need for third-party attestation, as well as lack of quantum safe encryption. Now, let us go quickly through 2 use case examples, one from the transportation industry and the other one from petroleum industry. The transportation industry example is the connected METRORAIL, and the first step is to connect or to build the METRORAIL itself, and the second step is to install the Internet of Things endpoints, such as these turnstiles in the metro stations, West Height turnstiles. And the third step is to install the the digital business platform itself. And the fourth step is to connect the Internet of Things endpoint to the Internet of Things platform. And the fifth step is to connect the customers to the customer experience platform. And the last step is to connect the ecosystem to the ecosystem platform. Having done this, we have now implemented the connected METRORAIL. And in addition to the benefit of its implementation, we can go again also byproduct benefits or other benefits, additional benefits, such as coordination of multimodal transportation networks and integration with door-to-door travel as a service. For example, we can use to integrate it with cycling hire bikes, transportation mode, for example. And to do this, actually, we should plan this interface in appropriate manner, and to plan it in an appropriate manner, we can leverage the artificial intelligence capabilities included in the data and analytics sub-platform by installing roadside sensors to count the number and the type of road users. And the sensors can determine automatically through artificial intelligence algorithms which types of vehicles is being used. This is an example for machine learning based artificial intelligence object detection. It is used to count the number of cycling bikes and to better understand the cycling habit to plan this interface with the connected METRORAIL. The second and the last slide is about petroleum industry operator. This petroleum industry operator installed SCADA and distributed control systems in the field to real-time monitor and control the well sites and the rig sites, and the well sites for production and the rig site for drilling. And the drilling data and the production data is acquired in real time and passed to the information system platform, where it is consequently passed to in real time also to the data and analytics platform, where it is intercepted here to do some sort of data in motion analytics through the event stream processing capability. And this is done in step A. And in this step, the purpose of this step is to do real-time cleansing and to have high quality data by removing the data errors on the fly while the data is still in memory, not yet written on hard disk or storage. And then it passes the cleansed data into the real-time operational intelligence capability, where step 2 is actually including identification of bottom hole pressure build-ups and drawdown. This was the last slide of my presentation, and I will distribute the slides, inshallah, through the event organizers, and you can contact me if you want to additional information or you have any questions about the subject. Thank you for your time.
Thank you so much. Thank you so much for your time. We really appreciate the information and knowledge you have shared with us. That was Alaa Mahjoub, former data management senior expert from the Department of Transport, United Arab Emirates.